Okay, we're going to do a proof today on the distance formula for cosines, and that formula is, let me select the pen here, that formula is cosine of a minus b, cosine of the quantity of a minus b, is equal to cosine a cosine b plus sine of a sine b. And the way we do this proof is we actually start with the unit circle. So let me draw that out. Let me try to... Okay, so that's close enough. Okay, and on this unit circle we will draw two lines, each one being its own radius. And so for this first line on quadrant 2, we're going to give that an angle A. So this line right here rotated from 0 all the way by the angle A. And the second line here in quadrant 1 rotated by in the positive direction, angle B, which means the angle between the two lines is A minus B. And then next we want to draw a triangle out of these two lines, and we put a third line here which makes a triangle. And what I'm going to do next is I'm going to redraw the triangle over here a little bit bigger so you can see it. So I'll try to make it look similar. Okay, so what do we know about this length right here? This length is the same, corresponds with this length right here, and we know that length is 1 because this is a unit circle. And the same would be true for this line, which is also a radius, so this length would also be 1. And then this length right here would be A minus B. So this angle right here, we call that A minus B. And then we're going to call this length right here C. So we can call this length little c right here. Okay, so when you see a triangle like this is a non-right triangle, and when you are working with non-right triangles, then you can really only use two different laws. One is law of sine and one is law of cosines. And in this case, it's set up so that we'd be using law of cosines. And so the law of cosines is c squared is equal to a squared plus b squared minus 2ab cosine big C. And big C is this guy right here. This is big C. This is the angle big C. This is little c, which refers to the measurement of this line segment. And really we could call this, for example, we could call this angle big A, and we could call this, angle big B, and then this distance right here is across from big B. So this is little b, so that's equal to 1, and then this distance right here is across from big angle A, so this would be little a. And then now we can just substitute everything in. So c squared is equal to a squared, and a is equal to 1, so that's just 1 squared, which is just 1, plus b squared, b is just 1, so 1 squared is also 1, minus 2 times a times b. So 2 times a times b, I'll just write that out. 2 times 1 cosine of big C, and big C is equal to a minus b. And then we can simplify this further, and then we get c squared is equal to 2 minus 2 cosine a minus b. And so this was from this equation that we ended up from. This was a result of the law of cosine. So next we're going to look at this blue line here from here to here. And what we want to do is we want to find the distance of C using the distance formula. So we could say that this has some, ordered pair x sub, let me get rid of that, x sub 1 comma y sub 1, and then this ordered pair is some x sub 2 y sub 2. And what's another way to write x sub 1? Well, we know that this point is a result of this line coming up by a positive angle b. So we can say this x sub 1 is equal to cosine of b. And then y is equal to the sine of b. And this just comes from, that sine of theta is equal to y, and then cosine of theta is equal to x. And if you're not sure about that, you can look at some of my other videos which explains that. And so we can use the same argument here. This line segment, which rotated in angle A, ends up at this ordered pair on the unit circle. And so x sub 2 would be equal to cosine of A, and then y sub 2 would be equal to sine of A. Okay, so now if we wanted to find the distance between these two ordered pairs, you're just going to use the distance formula. So let me scroll down a little bit, so a little bit more space. Okay, so we will draw the new x and y axis here so you can see it more clearly. And then we're going to say this point right here is x sub 2, y sub 2. So this would be x sub 2, y sub 2. And we know that's cosine of A, sine of A. And then we have this other point that's right about here. And then this is x sub 1, y sub 1. And that's also called cosine B, sine of B. And I'm just redrawing it over here so it's a little bit less confusing. We can just focus on the fact that we're just using the distance formula. Now this should look like some of the problems that you maybe did in your first year of algebra, or even pre-algebra, but definitely in algebra you would have done this. And so if you want to find the distance between two ordered pairs, you just use the distance formula. So let me scroll down further. So we want to find the distance C, right here, this is our distance C between these two ordered pairs. So we're going to use our distance formula. And our distance formula is, actually let me use white. So this is C. And then we're going to say the distance formula is C squared is equal to x sub 2 minus x sub 1 quantity squared plus y sub 2 minus y sub 1 quantity squared. And again, if you're not sure where this came from, you can look at some other videos, but this essentially comes from the Pythagorean theorem. So let's continue on. So x sub 2 is equal to cosine A, which we already established. So that's cosine A minus cosine of B. Actually, I'm sorry. Yes, that's cosine of B. And that's quantity squared plus y sub 2 is sine of A. So that's sine of A minus sine of B. Sine of B. Okay, so next we want to FOIL these two terms out. We have two giant terms here, and they're two terms because they're locked inside parentheses and they're squared. So we're going to FOIL these out, and that'll kind of unlock it out of the parentheses. So we have cosine A times cosine A, so that's cosine squared A. And then we have cosine A times negative cosine B twice, so then we end up with negative 2 cosine A cosine B. And then finally we have negative cosine B times negative cosine B, and that's positive cosine squared B. And then we do the same thing here, and you'll get something similar, which is plus sine squared A minus 2 sine A sine B, and then plus sine squared B. So now if we look at the different terms, we can see that some of these terms looks like they should be matched together. So for example, cosine A and then cosine squared A and sine squared A, if we put those together, it would look similar to this trig identity. Actually I should say cosine squared theta plus sine squared theta is equal to 1. And if we put cosine squared A plus sine squared A, that's going to be equal to 1. And then we can do the same thing with cosine squared B and sine squared B. So if we put these two together, that's also going to be equal to 1. So you'd have 1 plus 1. And then we have these final two terms here, negative 2 cosine A cosine B and negative 2 sine A sine B. And we can actually factor out a negative 2 from both of those terms. And we are left with cosine A cosine B plus sine A sine B, and that becomes positive because we factored out the negative 2. And then this is equal to c squared. So again, this formula right here, or this equation, and really this is, I could simplify this, so let me simplify this. This 1 plus 1 obviously ends up being equal to 2. So let's just make that into a 2. So this is, whoops, got to change it back to the pen. So we want, this becomes 2. And let me erase this so this isn't confusing anyone. So this result came from the distance formula. So this result right here came from the distance formula. And then this result came from the law of cosines. And since they're both equal to c squared, we can actually put them together. So let's go ahead and do that. And so when we use substitution, we can set them equal to each other. And what do we get? We get 2 minus 2 cosine A minus B. And that's equal to 2 minus 2 cosine A cosine B plus sine A sine B. And then we can simplify this equation further. We just subtract 2 off both sides. So then these all disappear. And then what are we left with? We're left with this giant term and then this giant term. And we can actually just divide negative 2 off both of these. So we're going to do that to both sides. And now what are we left with? Well, these are going to cross off, the 2 negative 2's, and then these negative 2's are also going to cross off. So we're just left with cosine A minus B is equal to cosine A cosine B plus sine A sine B. I hope that helps.